You can build a system designed to move incredibly fast, but if the core architecture is flawed, the speed will cause it to shatter. This happens regularly in product development. A team builds a minimum viable product, an MVP, launches it to the market, and waits to see if people buy it. They treat the launch as a binary test. If the market engages, they pour capital into scaling up. If the market ignores the product, they kill the project and move on. Viewing that first prototype as a final exam misinterprets the core of lean strategy. An MVP serves as an ignition switch. Its sole purpose is to start the build, measure, learn loop. When you treat that starting point as a destination, you lose the ability to reduce your risk. Every subsequent dollar spent scales a premise that was likely incorrect from the beginning. In high uncertainty markets, the build, measure, learn loop is the primary mechanism for a company's survival. The problem is how teams plan their execution. They read the name of the loop and try to follow it chronologically. They sit in a room and decide what they want to build. Once it's finished, they look at what metrics they can measure. Finally, they try to learn something from whatever numbers come back. This sequence consistently yields garbage data. You end up tracking vanity metrics like total app downloads or page views, which offer no direction on what the company should do next. To capture validated learning, you have to invert the logic. The entire strategy must be designed backward before any building occurs. Top technology teams use a diagnostic countermeasure called reverse planning. You start at the end with the learn phase. You have to identify the single riskiest assumption your project relies on, the specific unknown variable that will bankrupt you if it's wrong. Next, you move backward to measure. You define the exact actionable metric that will prove or disprove that assumption. No generic engagement stats, only hard conversion ratios. Only then do you reach build. You design the absolute lowest cost, smallest batch prototype capable of capturing that specific metric. Your execution will always move forward, but your strategy is mapped in reverse. Every line of code exists solely to serve a specific data gathering requirement. Consider an industrial startup that engineered predictive maintenance IoT sensors for heavy manufacturing. Their riskiest initial assumption was that factory managers required a complex, real-time 3D heat map to monitor the status of every machine. Moving forward with Loop 1, they built the web dashboard and deployed it across 5 different factory floors. This chart tracks their daily logins. You can see a spike on day 1 as users tested the system, followed by an immediate drop to absolute zero. When the team followed up, they found that factory managers spend their days walking the production line. They are never tethered to a desktop monitor. This flat line provides validated learning. It identifies exactly where the product fails to meet user needs before a single dollar is wasted on a polished 3D interface. They applied reverse planning to design their second loop. The new learn objective: will managers respond to instant preemptive alerts instead of a visual dashboard? The metrics to measure this became the open rate of the alert and the acknowledge rate, specifically how fast a technician was dispatched. For the build phase, they threw out the 3D graphics entirely. They spent 2 days wiring the sensors directly into a basic text message alert system. The results were immediate. Factory managers achieved an average response time of 3 minutes to incoming text alerts. The core product feature was discovered through the speed of cycling 2 completely different assumptions in just 14 days. Business consultants audit an organization's learning engine using a 5-point diagnostic framework known as the Shindanshi lens. First is cycle time. If an organization takes months to spin one loop, they are too slow. Efficient teams operate on weekly or daily cadences. Second is metric integrity. Teams must track hard, actionable user behaviors rather than comforting vanity metrics. Third is psychological safety. If a corporate culture penalizes invalidated assumptions, employees will simply hide bad data and push forward with doomed projects. Fourth is ego detachment. Teams cannot defend their original solutions against negative user feedback. They must be willing to adapt. Fifth is batch size. Experiments must isolate specific variables, avoiding monolithic, high-risk launches that test too many things at once. A failure at any one of these 5 diagnostic nodes will stall the engine, trapping the company in a state of high burn rate stagnation. There are two distinct operational tempos in modern business. One adapts immediately, while the other grinds through bureaucratic inertia. Competitive advantage no longer belongs to the company with the most capital or the most accurate day-one idea. The speed of these learning cycles creates a structural advantage. By iterating faster, a team can exhaust 10 failed assumptions in the time it takes a competitor to test one. This high-frequency feedback loop allows a company to arrive at a viable solution while competitors are still building their first mistake. When you design the loop backward, the definition of failure changes. Early invalidation of an idea provides high-fidelity feedback that guides you away from wasted effort. Applying reverse planning removes guesswork from product development. It pushes the product directly toward genuine product-market fit, while the rest of the market is still arguing over what to build first.